Hi guys. Okay, so let's look at the single displacement reactions. Single displacement reactions are those reactions in which one metal displaces another metal from its bonded state. And which metal has the power to do that and which one does not, that is governed by their placement on the activity series. We are going to be looking at the activity series in a few minutes from now, but before that, let us look at the applications of single displacement reaction. Okay, so just hang in for a minute. Okay, so single displacement reactions are actually used in the electroplating industry, where we see that the one metal is electroplated on another metal, commonly for the decorative purposes or for preventing it from corrosion. Okay, so these are just some of the examples where we see the electroplating of copper, of silver, of gold, of rhodium, and of chromium. So this is an example. On the right hand side, you will see there is a before and after. A silver ring, when it electroplated, looks like a gold ring, and it is actually electroplated. It has a plating of gold. So the kind of apparatus that is used is shown on the screen, and we are not getting much into detail, but we are just looking at the applications of the single displacement in creating these very beautiful gold plated objects. In this case, gold has been plated, but you can electroplate metals like copper and any other metal. But let's look at which elements are going to be, can be electroplated and which ones cannot, so that we're going to walk you through the activity series. Okay, so as you can see on the screen on the left hand side is the activity series. Here you will see the metals such as potassium, sodium, calcium, magnesium, aluminum, zinc, chromium, iron, nickel, tin, lead are placed above hydrogen. Why are they placed above hydrogen? Because when they react with the acids or when they react with water or with steam, they have the power to liberate hydrogen as a gas. And copper, mercury, silver, platinum, and gold, why are they placed below hydrogen? Because when they do not react with the acid, so they cannot liberate hydrogen, pretty much. And the order, if you see on the extreme left-hand side, the arrows pointing downwards. So the elements that are on the top are going to displace those elements that are at the bottom from their bonded state. So potassium will displace sodium, but sodium will not be able to displace potassium in the bonded state. So on the right hand side, as you can see, we have an element A. This is just a metal, and it is reacting with another compound. It's an ionic compound, BC. So this is just a general scheme in which A is going to break the bond of B and C, and it is going to liberate B and attach to the anion of the C. Of BC. Okay, so this is a very general scheme, and let's look at some of the examples and some of the reactions and whether they are going to work or not. So here is one example. If zinc reacts with zinc as a solid, okay, reacts with copper chloride, a solution of copper chloride. If you place zinc in a solution of copper chloride, is this reaction going to work or not? Yes, it is, because if you look at it on the left-hand side in the activity series, zinc is placed on the top and copper is way down at the bottom. And therefore, zinc has the power to liberate copper, and it is itself going to form zinc chloride, which is going to be soluble in water. And copper is seen as a solid, either plated or sitting in the solution. Okay, so this is one example. And why this works is because zinc is above copper in the activity series. On the other hand, is copper going to react the same way? No. If you take copper as a solid and you mix it with zinc chloride solution in the aqueous state, aqueous solution of zinc chloride, there is going to be no reaction. Okay, because copper is below zinc in the activity series. So this is one piece. Next, let's look at, can magnesium react with HCl? So here is your magnesium as a solid. Can this react with HCl? And yes, we will see that when magnesium reacts with HCl, it is going to give you magnesium chloride, MgCl2, and it liberates hydrogen gas. And this hydrogen gas is seen as bubbles. And this is the aqueous solution of magnesium chloride and HCl. So once you balance it, you are going to get 2 HCl and that's balanced. Okay, so why is this happening? Because magnesium is above hydrogen in the activity series. So once again, let's look at the activity series on the left hand side. If you look at potassium and sodium, they react violently with water. Calcium is going to react slowly with cold water. Magnesium, aluminum, zinc, and chromium are going to react slowly with steam, but rapidly with the acid. So this is going to be very fast reactions. On the other hand, iron, nickel, tin, and lead are going to react with the acids, but they're going to react with acids of a higher concentration, and it's going to be a slow reaction. So all these elements that are above hydrogen, as I said, if they are going to react with acid, all of them are going to liberate hydrogen gas, as you have seen in an example of magnesium with HCl. Copper, mercury, silver, and platinum and gold lie below hydrogen. Therefore, they will not show any reaction with acid. However, when copper mixes, copper as a solid reacts with silver nitrate solution, okay, silver nitrate solution, this is going to give you copper nitrate, CuNO3, and that's an aqueous solution, and it is going to liberate silver as a solid. Okay, you can make this silver. Okay, but this happens because copper is above silver. But on the other hand, if you have silver and just silver, you put silver in a copper nitrate solution, and this is going to be no reaction. Why there is going to be no reaction? Because silver is below copper in the activity series. So it does not have the power to displace copper from copper nitrate. So these are just some of the examples of the single displacement reaction. And I hope that you found it interesting and it was easy. Thank you. Bye-bye.